talking about sedimentary rocks, it's important to begin the discussion with a little bit of a review of the origin of these sedimentary rocks, which is sediments. We've looked at the weathering and the variety of types of weathering, and now we're going to address erosion, because this is how the sediments get moved from one place to another. So let's take a moment and review what we know about weathering and erosion as two separate processes. Now, we saw how weathering is involved in a couple of different processes. This is the degradation or the alteration of any rock into sediment. This is part of the rock cycle. This could be organic material also that is replaced by fluids. So either one of these things contribute to sedimentary rocks. The next thing we addressed was what the loose particles are made of. They could be rock, dust, small grains, gravel, all kinds of things. The organic material could be shells and bones and other material that is from an organic source. Finally, in reviewing our definition of the difference between erosion and weathering, we had erosion, which was the actual movement of the material by wind, water, glaciers, or even gravity. Weathering, on the other hand, was the breakup of the material through a physical, chemical, or biological process. And we saw that there were a variety of different weathering types in each of these physical, chemical, or biological activities. Now, we're not going to go into those again, but we can refer you to the previous video on weathering of sedimentary rocks. When we're talking about erosional processes or the transportation of these sediments, there are several ways that this can happen. And this is through material that is either carried along the bottom of a riverbed or the bottom of the ground by wind. And this has a number of names depending on how much that wind or fluid is moving the material. So we can have either material that is actually brought into the air and airborne, and we call this a suspended load. This could also be wind that is carrying it into the atmosphere, or it could be water that is moving at a significant speed where it can actually carry it along. Next, we have a process called saltation, where the materials or grains are bouncing along the bottom, either of the surface of the earth or the bottom of the ocean or a river. In other words, the velocity of that fluid is not enough to fully suspend the load in the atmosphere, but it bounces along, and that word saltation comes from the Spanish saltar, meaning to jump. Finally, you can have material that is rolling along or is pushed along the bottom, and these usually occur with the larger grains or boulders or heavier material. And this is where the wind or the fluid is not quite moving at a significant velocity where it can even jump. It just pushes it along at a much slower rate. Now, erosion is also rate dependent. In other words, the speed of erosion will determine or will be determined by how much water or wind you're throwing at your rock, right? So the more intense you're adding water, or the greater the speed, especially if water has other material in it, it's going to act to erode the rock a lot faster. And same if you have some chemical breakdown and you continue to add a lot of water and it's picking up other minerals, that may actually also contribute to being more of a solvent and further breaking down that material. So let's take a look at some of the factors that affect this rate of erosion. Plate tectonics. If you have rapid uplift of the land due to some kind of plate motion, that can expose surfaces to air or bring them down into contact with seawater. And again, you have two different processes going on, but this can contribute to eroding and weathering material. Climate is another factor that can alter the rate of erosion. So if you have a warmer, drier climate, that's going to behave very differently on the rock compared to a very humid, wet, and moist environment. The hill slope makes a big difference. If you're on a steep hill slope, most likely you will have mass transport or mass erosion or falling of material by gravity down the hillside. Your chances are greater when the hillside gets wet because gravity or the weight of that material is even greater. Vegetation can also act in two ways. One, it can hold up a hillside by retaining those steep hills with the roots and the trees holding up that material, or it may actually add to increase the rate of erosion where the roots are actually breaking down some of the rocks, as we've seen. And finally, we have human activity, where we are now covering the earth with more material like asphalt and not allowing rain and water to get into the ground. And so this is actually creating channeling effects where you get a lot of rainwater that goes into much smaller areas and therefore creating floods. We also are altering our landforms through mining and other activities that we do. So we play a big role in erosion. Here's an example of some of the mining from space, especially when we're talking about strip mining, where we level and totally change the face of that area that we're mining. Let's take a moment and look at how we transport sediments. And we can either do it with wind, with water, with glaciers, or some other kind of mass wasting event like a landslide, or even human activities where we push the material around or dig it out. So with wind and water, there's some very similar processes at play, and we'll take a look at those in a second. Glaciers have more of a physical process where they're gouging the ground and shoving material around, and we'll look at that as well. Now when we have wind, sometimes there are some features on the ground that can tell us exactly which way the wind was going, how much wind activity there was, and what kind of sediment was transported by that wind. So in some desert areas, you can actually see these little stalks of material coming out of the ground where the roots have played a role in retaining some of the sediment or trapping some of the wind-blown material. Now, sediments, when they go up in the atmosphere, especially if they're very light, fine ash or dust-like particles, they have to end up somewhere. And the light material we call loess. This is transported by the wind, and it's possible that 10% of the earth is covered in this kind of loess. And that dust will come from a couple of different sources. Mainly it comes from glaciers in certain parts of the country, where it's a pulverized rock that has almost turned into what we call a rock flour, and that is easily picked up by wind. We see that in the Midwest of the United States. A lot of the loess has a glacial origin. Other dust can come from deserts. Some of the finer material in deserts can be picked up by a windstorm. And we've seen images of those sandstorms, and that's a perfect example of transportation by wind. And then finally, we also have volcanic ash, where a very strong eruption can push ash many miles into the atmosphere, and if it gets high enough, it can be airborne for several days and actually move around the entire globe before it settles back down. So let's take a look in the United States where some of these big loess deposits are. We see many of them in the Great Plains and a few in the Pacific Northwest. The Great Plains are probably sediments derived from the glaciers that once covered Canada and the northern United States. Now in other parts of the world, the source of that material may be very different. In the Bahamas, for example, there are a number of calcareous aeolian deposits, and aeolian means a wind deposit, and those would most likely come from offshore. It could be the fine sand that is created from coral and other submarine material that gets washed up ashore, and if it's light enough or fine enough, it can be airborne, redeposited, and you might get some new sediments. Now here we have a combination of fine calcareous sediments, and it looks like the remains of an old reef that has been also elevated to the surface. Here we see an image of sediments entering the Gulf of Mexico from the continent. So you can see that erosion is a very active process. And so when you have rain and wind pushing that topsoil, pushing the sediments and eroding the rocks, they have to go somewhere. And usually the lowest place is sea level. And after that, everything gets washed into the ocean. So from satellite imagery, we can easily see how material off the coast will wind up into the ocean. If we look at glaciers and ice as a transport agent, you can imagine a glacier scouring the topography as it moves along and works its way toward the ocean. And as it's moving and pushing this material, you can see long strands of it here in this Piedmont Glacier, and much of it ends up as moraines at the very end where the glacier is melting. Not only do you see it there, but you also see glacial ice melting and carrying it along the surface of the glacier as it melts, particularly as the glaciers warm in the summertime. Now it's important, once we have all this loose material, to consider how you're actually going to turn it into a sedimentary rock. We do this through a process called lithification, and this is taking any loose material and turning it into a solid rock. So you're going to need a few things. You're going to need some pressure and some fluids to bind it together or to move it around. And when you apply this pressure, this is the compaction process. You need usually quite a few layers or a thick layer of sediment to produce that natural weight that'll compress the sediments at the bottom. And then to cement all that loose material, you need some fluids, and usually that'll be a calcite, a silica, or some kind of an iron oxide. And this material provides your cement to bind all that loose material together. So quite often in sediments, you'll see the pore spaces are all filled up with this cement. And once you have your sediments, then you have basically an imprint of how they were laid down in forms of beds or strata. And so they're going to take on similar colors for similar time periods. It may have a different color if it's got some other impurities or some other material that has come into play. So for example, you could have beach sands and then maybe a thin layer of darker material, which possibly could have been a river that overflowed with mud and clay onto the beach sand. And so you might get these different layers and beds, as we call them. But the bedding planes will separate the different strata, and the oldest beds in general are below the younger beds, unless the whole thing has been turned over with some grandiose fold. And we'll talk about folds separately. Some of these beds may contain fossils or basically any remnant from that original material. Now it's interesting. As we continue to explore our solar system, there are numerous observations of what looks like beds or strata on Mars and other places. And this highly suggests that there was some kind of fluid at one time running over the surface of Mars.